process for solving a system of three equations with three variables expands on the processes we've already established for solving a system of two equations with two variables. To start off with, in example 1, we'll number each of our equations to give us an easier method for referencing the three. And we'll outline our process that we'll use to solve this system. First, we'll want to choose two of those equations and eliminate one variable. We can choose any pair that we want, and we can choose to eliminate any variable that we want. It can help to look at our system and determine which variable might be easiest. In this case, I'm going to start off with equations 1 and 2. What we need to do is choose a variable to eliminate. In this case, I'm going to look at eliminating the x variable, and in order to do that, I'll multiply equation 1 by -2. This will update our first equation to become -2x plus 4y minus 6z is equal to -14. Our second equation remains unchanged. And now we can add those two equations together, and we'll see that our x variables cancel out, leaving us with 5y minus 5z is equal to -15. Our next step will be to choose a different pair of equations. But now we have to make sure that we eliminate the same variable. So we can choose any pair as long as it's not 1 and 2. I'll choose 1 and 3. So we have our first equation as it was originally written. And our third equation. We have to look at eliminating the same variable. So in order to do that, we'll multiply equation 1 by 3, positive 3, to give us 3x minus 6y plus 9z is equal to 21. And equation 3 remains unchanged. Adding these two equations, we'll see that our x variables cancel out, leaving us with -4y plus 7z is equal to 18. What we've done now is created two equations, which we'll call A and B. And our next step in this process will be to solve that system of two equations that we've created. So this system consists of equation A, which is 5y minus 5z is equal to -15, and -4y plus 7z is equal to 18. To solve this system, we need to look at eliminating one variable and then use the methods we've used previously to solve that system. What we'll look at doing is eliminating the y variable. In order to do that, we'll multiply our first equation by 4 and our second equation by 5. So equation A will become 20y minus 20z is equal to negative 60. And equation B will become negative 20y plus 35z is equal to 90. When we add these two equations together, our y variables cancel out, leaving us with 15z is equal to 30, or z is equal to 2. So we found our first variable, z is equal to 2. What we need to do is take that and substitute back into some of our previous equations. So we'll start with equation A, which was 5y minus 5 times z, which we now know to be 2, is equal to negative 15, which will give us 5y is equal to negative 5, or y is equal to negative 1. Now we can go back to any of our original three equations, 1, 2, or 3. We'll look at equation 3, which was negative 3x plus 2 times y, which we know is negative 1, minus 2 times z, which is positive 2, is equal to negative 3. So we can look at simplifying this equation and then solving for x to get x is equal to negative 1. Now that we have all three of those values, we have our solution to this system, which is the ordered triple xyz, which in this case is going to be equal to negative 1, negative 1, 2. To confirm that that solution is correct, we could take those values, substitute them back into each of our original three equations, and what we should see is that they would make all three of those equations completely true.